In this video, we are going to discuss bisection method, and we are going to solve the equation in A and B, which are related to this cubic polynomial equation. So let us start with A, which says show that the equation has a root in the interval between 2 and 3. So let us call our variable A to be equal to 2 and our variable B to be equal to 3. So for S is equal to A, that is substituting A is equal to 2 in this equation, we are going to have minus 9, which is less than 0, that is negative. And for S is equal to B, we are going to substitute B is equal to 3 in this equation, and we are going to get 6, which is greater than 0. So according to intermediate value theorem, if our f of A and f of B have opposite signs, so that shows that there is a root between A and B. So in our case, f of A is less than 0, which is negative, and f of B is greater than 0, which is positive. So the signs are opposite, which shows that there is a root between A and B. And this intermediate value theorem will play a vital role in solving the B part, which is using bisection method to determine the root between 2 and 3 correct to 3 decimal places with an interval with accuracy of less than 0.02. So let us start solving B. We are going to use this iteration table for our solution, and the lower part of the interval will be our starting A. So I will have 2.000, and our starting B will be the upper part of the interval. So I will have 3.000. So the condition is we should continue our iteration until the interval with accuracy is less than 0.02. So I will continue with my iteration until B minus A is less than 0.02. So I have already computed my f of 2 and f of 3 from question A, which involves substituting x with the appropriate value in this cubic polynomial equation. So f of A is just minus 9. So I have minus 9.000, and f of B is just 6.000. So the key part of bisection method is bisecting the interval by 2. So that is finding the midpoint between the upper and lower part of the interval. So for this case, 2.500. So I then have to find my f of m. That is substituting x as 2.5 in this equation. So doing that, I will obtain minus 3.375. So from this graph, you can see that I have my x in the horizontal axis and f of x in the vertical axis. So my f of 2 is just minus 9, and my f of 3 is just 6. So for 2.5, which is between 2 and 3, I know that my f of 2.5 is minus 3.375, which is somewhere here. So in order to match these points, as you can see, I can't go between 2 and 2.5. So it is between 2.5 and 3. So that means my solution is between 2.5 and 3. So for my second iteration, 2.5 will replace 2, and the upper part will still be 3. So now what I need to do is to test my condition. So B minus A is just 0.500. So I have not met my condition yet. So I already know that f of 2.5 is just from here minus 3.375, and f of B is still 6.000. So now I just need to find the midpoint of the interval. So that is 2.750, and f of 2.750 will be 0.797. So using this graph for iteration 2, so we can see that the midpoint is just 2.75, and f of 2.75 is just 0.797, so which is somewhere here. So in order to match the 2 points or the 3 points, you can see that I go between 2.5 and 2.75. So now it means my lower limit for iteration 3 is still 2.5 and my upper limit is 2.75. However, I don't have to depend on the graph method in order to know my starting lower and upper limit of the iteration. So I can do that using the intermediate value theorem, which we have seen earlier, and which said that provided that f of a and f of b have opposite signs, then there is a root between a and b. So if you look at the first iteration, my f of a is negative and my f of b is positive, which means the condition is met. So if I find my midpoint and f of m turns out to be minus 3.375, so in order to maintain the condition, it means my m will have to replace the a. So in the second iteration, a will turn into 2.5 in order to have the negative positive sign condition. So for the second iteration, my m is 2.75 and I found my f of m to be 0.797. Now it is positive. So it is b that gave me positive in the previous iteration. So it means my m will now replace the b. So 3 will turn into 2.75. So that is how you have to keep on doing. So now I have to test my iteration condition. So 2.75 minus 2.5 will just give me 0.250. So I have not met my condition, so I have to continue. So f of a will just be equal to minus 3.375 minus 3.375, and my f of b will just be 0.797. So my midpoint is now 2.625, and f of 2.625 will be minus 1.412. So you can see my f of m is negative. So in order to maintain the intermediate value theorem condition, my m will then replace my a, because it is a that gave me negative in the previous iteration. So I have 4. So I will have 2.625, then b will be the same, 2.75. So I have to check my iteration condition. 2.75 minus 2.625 will just be 0.125. Now my f of m is just minus 1.412. My f of b is 0.797. So the midpoint between 2.625 and 2.75 is just 2.688, and f of 2.688 will be minus 0.330. So you can see it is negative, and it is f of a that gave me negative. So it means my m will replace a. So I will have 2.688, then 2.75. So I have to test my iteration condition. 2.75 minus 2.688 will just be 0.062. So I have not met my condition. I have to continue. So let me just pass forward until the last iteration. So at iteration 7, my starting a is 2.704 and b is 2.719. So if I test my condition, I will end up with 0.015. So you can see 0.015 is less than 0.02. So it means this is my final iteration, and my approximate root that satisfies the condition given in the question will just be the midpoint of these 2 points. So I will have 2.704 plus 2.719 divided by 2. So to 3 decimal places approximately, I will end up with 2.712. So if you want to watch interesting tutorials on linear algebra, watch the playlist on the screen. Please like and subscribe to the channel. Thank you for watching.